Next heading, law of conservation of energy. Law of conservation of energy. In the case of a freely falling body, okay? In the case of a freely falling body. Look here. Suppose this is an object at A, okay? And here, object at A, it is at a height h. It is at a height h. Okay. The height h. Here, when this body is falling, during its motion, this body moves through this point B. Moves through this point B. Moves through this point B. An instant. Then it touches the ground. These 3 points were constrained. It just touches the ground.
Sir,
that is C.
I got disconnected, so sir.
Pardon?
Sir, I got disconnected, so can you
Let us just
repeat?
An object is at the point A. We are dropping it down on its motion on the way. After traveling a distance x, object going through the point B, then it just touches the ground. So these 3 points, total energy we are going to calculate. You write down. First draw diagram. Draw the diagram first. Right. Let us consider a body A. Let us consider a body A is placed at the point A, at a height h, from the ground.
Body placed.
Let us consider a body of mass m. Let us consider body of mass m is placed at the point A, which is at a height h from the ground. Okay. Then write at A. At A, potential energy. Potential energy EP is equal to mgh. Kinetic energy EK is equal to half mv squared. That's equal to 0 because V is equal to 0 at this point. Therefore, total energy ET is equal to mgh plus 0. That's equal to mgh. Equation number 1. Finish it.
Sir, over.
Now, during its free fall, during its free fall, at the instant, the object is at A. It's on motion now. The object is at A. After traveling a distance x, where its velocity is v, v, then potential energy, right? Then potential energy EP is equal to mg. For calculating potential energy, we need height
Sir,
minus
sir,
x.
where you wrote energy at object at A.
Yes,
Object
sir.
at B.
It's object at B, right?
During its free fall, at the instant the object is at B, after traveling a distance x where its velocity is v, then EP is equal to mg h minus x, this height, h minus x, and ek is equal to half mv squared. But v squared is equal to u squared plus 2gs. U is equal to 0, s is equal to x. Then v squared is equal to 2gx. Then ek is equal to half m into 2gx. Half cancel. Ek is equal to mgx. Then total energy. Then total energy Et is equal to EP plus Ek. Et is equal to EP is mgh minus x, and Ek is equal to mgx, and Et is equal to mgh minus mgx plus mgx. Cancel. Et is equal to mgh. This equation number 2. At the instant as the object touches the ground, where h is equal to 0 and velocity v is equal to 2gh, isn't it? Because same formula, distance traveled is h, because from this is x, but when it reaching here, travel a distance of h. Clear?
Yes, sir.
Isn't it? 2gh. You understood this formula, right?
Yes, sir.
V squared is equal to 2gh. Then its potential energy is equal to mg into 0, 0. Ek is equal to
So can you explain how v square equals 2gh?
how v squared is 2gh.
Yes, sir.
Have you seen this formula? V squared is equal to u squared plus 2gs, right?
Yes, sir.
u0 initially, s is x. In this case, s is equal to h.
Alright, got it, sir.
Because from here to here, when it travel, it is h distance traveled.
Yes,
Sir,
sir,
in the
got
second
it.
case, potential energy, why didn't we take mgx?
MGX cancelled.
No, potential energy we are taking from down to up, isn't it?
Oh, okay, sir.
Height, h we need.
Okay, sir.
Then Ek is equal to mgh. Okay, we can write half mv squared, and Ek is equal to half m V squared is 2GH, it's cancelled. Then EK is equal to mgh. Therefore, total energy is equal to 0 plus mgh. Then ET is equal to mgh, equation number 3. From equation 1, 2 and 3. From equation 1, 2 and 3.
The
From
energy is
equation
same.
From equation 1, 2, 3, 1, 2 and 3. It shows that the total energy remains same throughout its free fall. Total energy remains same throughout its free fall. Then graph.
Sir, can you go back 1 second?
Height. Energy.
Sir, can you go back to the last slide?
Sir, graph of what, sir?
Graph of this energy change.
Law of conservation
Hmm.
energy. Yes.
Is it over?
Yes, sir, done.
Yes, sir.
The following graph shows the variation of energy with respect to height in the case of a freely falling body.
So the following graph shows
Variation of energy with respect to height in the case of a freely falling body. This light green lines are dotted line, okay?
Okay, sir.
This is potential energy, EP. Potential energy. And this fall is kinetic energy, EK. And total energy is this. That means height increases, potential energy increases, but kinetic energy decreases. Total energy always same. Once you finish the graph, please tell me.
Sir, over.
Next, power. Power.
Sir, can you
Right.
show again what was EP and what was EK? Okay, sir.
It's over.
Yes, sir.
Now power. It can be defined as rate of doing work. It can be defined as rate of doing work. Power can be defined as rate of doing work. Then power is equal to W by T, joule per second. Power is equal to rate of doing work. That is P is equal to W by T, joule per second. P is equal to W by T watt. If W is equal to 1 joule, T is equal to 1 second, power is equal to 1 watt. One watt can be defined as, now 1 watt can be defined as that amount of power. 1 watt can be defined as that amount of power. One watt can be defined as that amount of power, so that 1 joule of work is done in 1 second. 1 joule of work is done in 1 second. 1 joule of work
The
is done.
amount of power.
SI unit of power, watt. 1 watt can be defined as that amount of power. 1 watt can be defined as that amount of power, so that 1 joule of work is done in 1 second. 1 joule of work is done in 1 second. So SI unit is what? Commercial unit. Commercial unit. 1 kilowatt is equal to 1000 watt. And 1 horsepower is equal to 746 watt. When you purchase motor and all for pumping water, machineries, car and all, they say in horsepower. 1 horsepower means 746 watt. If you have around 0.5 horsepower, we can pump water to 1 floor and all. Okay, just 1 floor, one like that. Around half horsepower only required. Have you finished?
Yes, sir.
Yes, sir.
SI unit is what? Other two are commercial unit. Next. Relation between power, force and velocity. Relation between power, force and velocity. Relation between power, force and velocity. Power is equal to work by time. Watt. And power is equal to work is force into displacement by time. And power is equal to force into displacement time is velocity. Or P is equal to F dot V. It's again dot product. Power is equal to force into velocity. Is it over?
Yes.
Now relation between kinetic energy and linear momentum. Kinetic energy and linear momentum. The kinetic energy EK is equal to half mv squared. Numerator and denominator we are multiplying by m, half mv squared. Here into m divided by m. So equation has no change. EK is equal to half m into m, m squared, v squared divided by m. Then EK is equal to m into v is p. We know p is equal to m into v. So here m squared, v squared is p squared. Half p squared by m. Then p squared is equal to 2 m ek. P is equal to root of 2MEK. So this formula and this formula are important. Is it clear?
Yes.
Problem based on this, okay? A heavy body, right? A heavy body and a lighter body. A heavy body and a lighter body are traveling with the same kinetic energy. Are traveling with same kinetic energy. Which body possesses more linear momentum? 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 Okay, look here, how we are going to solve it. This problem. A heavy body and light body having same kinetic energy. So now we have the formula EK is equal to half P squared by M. Heavy body and the lighter body have same kinetic energy. That means EK is constant, half is constant. Then we can say P squared is proportional to M, P is proportional to root M, isn't it?
Yes.
Therefore, heavy body will have more linear momentum. Okay. Right. EK is in half P squared by M. Here, kinetic energy is constant. Therefore, P squared is proportional to M. And P is proportional to root M. Therefore, if the two bodies having same kinetic energy, heavier body will have more linear momentum.
And then what about the half?
That's constant, right?
The half is also constant.
Then half is constant, right? Kinetic energy constant, half is constant. Both are constant. Variables only P and M.
So can you repeat the last statement?
P is proportional to root of M. So linear momentum is directly proportional to square root of mass. So heavier mass will have more linear momentum. Okay, is it over?
Sir, is this the
Yes, sir.
topic after graph of law of graph?
What?
Sir, is this the topic after the graph?
This is the topic?
After the graph, sir, after the graph.
Yes. Next. A heavy body and a lighter body. A heavy body and a lighter body have same linear momentum. Which one has more kinetic energy? A heavy body and a lighter body have same linear momentum. Which one has more kinetic energy? A heavy body and a lighter body have same linear momentum. Which one has more kinetic energy? CK is equal to P squared by 2M. Heavy body and a lighter body having same linear momentum. That means P is constant, 2 is constant. Then EK is inversely proportional to M. So lighter body will have more kinetic energy. Clear? Heavy
Yes, sir.
body and the lighter body having same
Yes,
momentum.
sir.
So P is constant, 2 is already constant. So EK is inversely proportional to M. If two bodies having same kinetic energy, same linear momentum, then lighter body will have more kinetic energy. Examination sometime instead of asking lighter body and heavier body, they may ask truck and the car. So truck you have to take as heavier body, कार्य അവിടത്തേക്ക് സ്ലൈഡ് പോകണം.
Okay, sir.
Next question. The linear momentum of a body, the linear momentum of a body increases by 20%. Linear momentum of a body increases by 20%. What will be the percentage increase in the kinetic energy? What will be the percentage increase in the kinetic energy? What will be the percentage increase in the kinetic energy? Always remember formula for percentage increase, okay? This is a formula.
What will be the percentage increase?